Hello all. So in this lecture we'll see more on this SQL statements. So this is the outline of this lecture. We'll see comparisons involving null values, then three-valued logic, then nested queries, correlated nested queries, exist, not exist, then join, then also natural join in SQL. So comparisons involving null. So in SQL, we have various rules for dealing with this null values. So null, usually it may be a missing value, or it might be we have three different interpretations in SQL for this null value. One, it may be unknown value. So unknown value, for example, a person's date of birth is not known. So it may be represented by null in the database. And in the second case, null may be an unavailable or withheld value. For example, a person has a phone number but does not want it to be listed. So it is withheld and represented as null in the database table, or it may not be an applicable attribute. Then also we may enter null value in the table. For example, an attribute last college degree would be null for a person who has no college degrees because it does not apply to that person. So these are the three different cases where null values may be entered in the database. So when null values are there in the tables, we may have to compare. We may have to compare with some other value. So what happens when we compare some 25 with null? So what will be the result? So in order to do that, we have a three-valued logic in SQL. Three-valued logic. So we have already seen this two-valued logic in binary and all. Similarly, we have a three-valued logic in SQL. So that is true, false, and unknown values there. That is null value. True, false, and unknown. So if it is an and condition, then true. You know about true, true and true is true, and true and false is false. And if it is true and unknown, it will be written as unknown. And if it is false and for unknown, then the result will be false. It is not unknown, it will be false. The other, in all the other cases, it is unknown will be given as written. Then for the or case, here if it is true and unknown, then automatically it will be true. True or unknown, it will be true. And all the other cases, it will be unknown itself. Okay. Then in the case of not unknown, if there is an unknown value, then the resultant will also be an unknown value. So these conditions, these logic will happen inside this SQL statements. When we compare some value, we want to check something. For example, for this is an example for that. Retrieve the names of all employees who do not have supervisors. So we have to retrieve all the employees who do not have supervisors. So all employees may not have supervisor. Some may be bosses of the company. So those people may not have supervisors. So in this case, we are checking with some null value. So null value comparison will be needed. Select F name comma last name from employee where super SSN is null. So we can compare the super SSN whether super SSN is there or not. For that, for this comparison, we use this kind of is null value. When complex queries are there, there might be values where we have to check null with some other value, null with 25,000. So what will be the result? Like that, we have to give some result. For that only, we use this three-valued logic. Next, we will see nested queries. So we have already seen the simple queries like select star, select from where clause. Now we can have nesting inside these queries. So nesting means it will be a complete select from where blocks within another SQL query. So it will be another SQL query will be inserted in a SQL query. That is, we have a select from where block, and inside it we will be inserting some more another SQL query or another select from where query. So we know when you have studied C and all, you have already seen nested for loop like that. So nesting means one query inside another query. So here we can have nested queries also in SQL. So we call the outer query as the outer query. We call it as the outer query, and the inner query as a nested query. So nested queries can also appear in the where clause or the from clause or the select clause or other SQL clauses as needed. So this nested query can appear anywhere. It can appear inside this where clause of another select clause, or from clause of another select clause, or inside the select clause itself it can appear, or for any other SQL clause also this query nested queries can occur. So we will see some examples. So we have already seen this example. Make a list of all project numbers for projects that involve an employee whose last name is Smith, either as a worker or as a manager of the department that controls the project. So this is the query we need to write. So we have already seen this when we studied union example. So when in the previous lecture we have already seen to write this query using this union operation. So this was the thing that we have written there using union. So union like this. So this is one case where we'll check whether he is the manager of that department uh, working on that particular project, and he is manager of that department, that whether Smith is manager of that department. Then this is another project, and this is the project numbers. This will list all the project numbers where Smith works as an employee. So this lists all the projects which where Smith is the manager. And when we do the union operation, we will get this thing: list of all project numbers for projects that involve an employee whose last name is Smith, either as a worker or as a manager of the department that controls the project. So this is the union of these two queries. So we have written this union. So this query, this same query can be replaced using a nested query. So we will see how to replace this with a nested query. So this is the nested example. So what we have to do, the same thing, we have to list the project number from project where P number in. So in operation is a comparison operation. It is a comparison operator, like equal to, it is a comparison operator. So what it does is it will check in a set of elements. So if we want to check a set of elements, we have to use this in operator. So there will be many number of project numbers that will be there. So it is a set. So this P number should be compared with a set of elements. So this will return a set of elements. So in order to compare with a set of elements, we use the in operator. So where P number in, we have to select this. So this will list all the projects, will list all the project numbers which are managed by this Smith, where Smith is the manager of that particular department which controls that project. So this P number, so it will select all those things. Then we have one more condition here, P number in. So we have to see whether Smith works for that particular project number. So this will list all those things. So instead of writing that union, so this is known as nesting. So we are writing a nested query inside this where clause. So it is written inside. So this is a select statement, and we have a select from where clause inside this where. Okay. So this is known as a nested query. So we will get the same result. So this is also same. This query and this query is the same. So we can write queries in different manners and using different things. So this actually lists all the this condition. So list of all project numbers for the projects that involve an employee whose last name is Smith, either as a worker or as a manager. So this will list the manager, the Smith as manager for all projects which are controlled by that particular department, and this lists all the project numbers where Smith actually works in. Okay. So this is actually a set operation. Okay, we will get a set of project numbers here. So we'll compare this P number with this thing. Okay, we have to compare this, and we have to give the result. That's why we use the in operator. So we'll see another example for this nested query. So this is another example. So here we have to select a distinct ESSN from works on, where we have given two attributes here, P number and hours, and in select p number and hours from works on where ESSN equal to 1, 2, 3. So this ESSN is actually of John Smith. Okay, John Smith's ESSN number. So actually what this query does is it will select the ESSN of all employees who work for the same project hours. So same project and number of hours in combination on some project that John Smith works on. Okay, if John Smith works on a particular project number 2 and he had worked for 25 hours, if there are any other employees who had worked for that project number 2 and 24 hours, all those employees will be listed here. So for that we use this nested query. So this is just for your knowledge. You need not by heart all these things. So you can write these queries like this. So so nested queries can be written like this. So in is a comparison operator. We have other comparison operator also. If this results only in a single row, if it results only in a single tuple, then you can simply use equal to operator. So if this results in more than one row, then it should use in operator. If it is only a single row, that is will be returned from this operation by the select statement. So this will be a table. So if it returns only a single row, then you can simply use equal to operator to compare. Okay, we have to just compare this PN number with that PN number and hours with that PN numbers. But here it may be more than one row. So that's why we are using this in operator. So this is another example. So this in operator, there are different comparison operator. All the comparison operators can be used here equal to, equal to, greater than or equal to, less than or equal to, not equal to. All those operations can be listed here. This is another example. So this returns the names of employees whose salary is greater than the salary of all employees in department number 5. So this will return the names of all employees whose salary is greater than all the salaries of all the employees in department number 5. So whoever has greater than that the employees that who are working in salary department number 5 will be listed here. So we are selecting last name and first name from employee where salary greater than all. So greater than all, greater than some. So all these are comparison operators. Okay, you can have different greater than all, greater than, equal, less than all, greater than or equal to all, like that. There are different comparison operators. Just you have to understand that there are things when you write more SQL complex queries and all, you will be using all these things. For your syllabus, we require only the this much thing. So salary greater than all, select salary from employee department. So this selects all the employees who are working in department number 5. So salary of all employees who are working in department number 5. Then it is compared with the salary. Okay, with the salary, and so we can compare each element with the whole rows, and it will return, if the salary is greater, then it will return the first name and last name. So there are different comparison operators. Greater than all or equal to any is there, equal to any. Then we have less than, greater than any, greater than or equal to, less than or equal to, and not equal to. And this can be combined with any operator. So equal to any, greater than any, less, greater than or equal to any, like that. There are different comparison operators. So we need not learn all these things and all. We have to learn only about this nested query. So this is an example for nested query. So you have to learn what is nested query, and you should be able to write an example for this nested query. Then this is another example for a nested query. Here you have to retrieve the name of each employee who has a dependent with the same first name and is the same sex as the employee. So we have to retrieve the name of each employee who has a dependent with the same first name. The dependent's first name should be same and is the same sex. The sex also should be, if it is male, that dependent should be also male. So this is a query. So we can write like this: select e dot f name. So we are using aliasing. So employee as e as aliasing, because here we are using this because we need to compare that SSN values. So sorry, sex values. So we have employee sex and dependent sex. In both the tables, the attribute name is sex. So we cannot write sex equal to sex. For that, we are using this aliasing. So we use employee as E, and we are going to find out the employees in, we'll be comparing with this thing, select d dot essn. So d is dependent, so d dot essn from dependent as d, where, so we have to check e dot f name equal to d dot dependent name. So this is a condition, same first name. So we'll be checking whether employee's first name and dependent's name are same, and the sex is also same. So if there is some employee that is there, all those SSN values will be returned, and this ESSN will be compared with the DSSN. So we will be comparing with ESSN, and if there is some same ESSN, then that E name and first name and last name will be returned as a output. Okay. So this is also an example for nested query. Okay. Next, we will see correlated nested queries. So, correlated nested queries means whenever a condition in the where clause of a nested query references some attribute of a relation declared in the outer query, the two queries are said to be correlated. So, if you see the previous example, in this example, we can see that we have written, this is the inner query. So in this inner query, we are comparing the sex with the employee sex. So there is some relationship between this. Also, this department name and F name is compared. So we are comparing with the employee, that is the outer query. So we are comparing the inner query, some attribute, with the outer query's attribute. So then these two are known as correlated queries. So this is known as correlated queries. Okay. So we are if we are comparing some attributes of inner query with outer query, then they are known as correlated queries. So that's what we have written here. Whenever a condition in the where clause of a nested query references some attribute of a relation declared in the outer query, the two queries are said to be correlated. So the previous query was a correlated query. So in the case of correlated query, we need not write a nested query. So without writing also, we can use this kind of select statement also. It will result in the same thing. Select e dot f name, e dot last name from employee as e and dependent as d, and where e dot ssn equal to d dot essn, and e dot sex equal to d dot sex, and e dot f name equal to d dot name. So using this conjunction operator, we can simply write the select statement without that nesting. Okay, so that is known as correlated queries. So if we have correlation between inner and outer query, we can write this as a single query. So there is no nesting and all. We can simply write this. So this will simply compare ESSN, that is employees SSN, with the dependent ESSN. So these two will be compared. And if it is equal to, then it will compare with whether that sex are equal. If that is also same, then we will compare whether this will be same. Then if all the conditions are satisfied, then we will get the first name and last name of that thing. So these are known as correlated queries. So this is known as a correlated query. So correlated query can actually be replaced by a single select query. Okay. So another example is exist. So exist, it is a Boolean function that return true or false. So this is another function in SQL. So exist and unique is there. We will learn only about exist. Exist function, it is a Boolean function that returns true or false. So it can be used in a where clause condition. So we usually use this in a where clause. So that condition will return either true or false. So it is used to check whether the result of a nested query is empty, that is contains no rows or no tuples in it or not. So results of exist is a Boolean value true if the nested query results contain at least one tuple. So if there is a nested query and if that nested query returns some rows, then it will be false. Okay. If it will be true. So exists is a Boolean value true if the nested query results contains at least one tuple. If there is at least one row that will be returned, then it is known as it will be true. This exists function. Okay. False if the nested query results contains no tuples or no rows. If no rows are returned, then it will be false. So we'll see an example, then you'll understand. So retrieve the name of each employee who has a dependent with the same first name and is the same sex as that of employee. So we have already seen this query. This is a correlated query, and we have already seen. So we can write. We can check like this. So we are using this exist in the where clause. And if there are any rows that will be there, if there are any rows that will be returned, then this will return a true value. So here we are checking the actual condition. So we are selecting all the rows from dependent as D, where E dot ESSN equal to D dot ESSN and E dot sex equal to D dot sex, and E dot FName dot equal to D dot FName. So if there is some rows that are satisfying this condition, then this will return true. So when this clause becomes true, we will get the first name and last name of that particular employee. So this is the use of this exist. Okay, exist. So exist will return true if at least one row is there. If at least one row is got as output from this inner query. So exist is used in where clause of nested queries. Okay. So if there is no dependent which satisfies this condition, then this will return false. So this selection statement will return an empty table. Okay. So this is exist, and similarly not exist is also there. I will show an example. Retrieve the name of employees who have no dependents. So we can use not exist also. Select F name last name from employee. Where not exist, select star from dependent. Whereas we have to simply compare the SSN of this employee with employee SSN. So if there are no if there is any employee that with whose SSN is not there in dependent, that means he does not have a dependent. That employee does not have a dependent. So we have to simply compare. We will be selecting from dependent where SSN equal to ESSN. Then not exist. So not exist can also be used. Okay, not exist is opposite of that exist. Okay. Then joined tables in SQL. So we have already learned this join operations in relational algebra. So those join operations can are also present this in this SQL also. Okay, join table. So this permits users to specify a table resulting from a join operation in the from clause of a query. So from clause we can join some tables. So usually if you see from clause is actually some relation here. So instead of this relation, specifying a relation, we will join some two tables. So we will get a join of those two tables, and the resultant will be taken from that join of those tables. For that we can use this join tables. Okay. So for example, if you want to retrieve the name and address of all employees who work for the research department. So we have already written this query in the, I think in the 25th or 26th lecture, when we started learning the select statement. This was the first query we have written. So if we want to retrieve the name and address of all employees who work for the research department, then we can simply write like this. Select first name, last name, address from employee, comma, department, where D name equal to research and this D number equal to D number. So one D number is for employee and this D number is for department. So we'll simply, whenever these two conditions are satisfied, we list that first name, last name, and address. Okay. Now this is actually join of these two tables. Employee and department tables are joined together. Okay, we can join these two tables and get the result. using the join operation. So we will see an example for the same thing using the join operation. So here first name, last name and address, and what we are doing is employee join department. So we are joining this employee and department table on condition. What condition? Department number should be equal to D number. So D number is department D number, and D number is employee D number. So when on these conditions, we will join these tables. Okay, we will join those tables and we will get a new table. Okay, we are forming a new table, joined table, and from that table we will select dname equal to research, and we will list the first name, last name and address. So this join on, this way we can join two tables. So the keywords that are used is join and on. Okay, then we can specify so attributes of such a table are all the attributes of the first table employee. So when we join, what we will get is the attributes of the all the first table will be listed, followed by all the attributes of the second table department. So we have already learned about this join operation when we learned relational algebra. The same thing is applicable here also. So employee attributes will be listed first. After that, the second table department attributes will be listed. Okay. This is a join operation we will get, and from that we will select only first name, last name and address where d name equal to research. Okay. Then we have different kinds of join. We have already learned natural join, eq join, outer join, inner join, left outer join, like that. There are different joins, but you'll be seeing only this natural join. Other joins are also there. Just for your knowledge that we have this join operation, you will see this join operation, and we can write natural join also, natural join. So natural join, here first name, last name and address, the same query, it is written using this natural join. So the only thing here is here we have specified this department number equal to D number. We are specifying that condition. In natural join, we won't specify the condition. If you remember, when you learned that relational algebra, we have said that we won't be specifying the condition in natural join. The only thing is, what it does is, if we want to perform employee natural join with department, what we have to see is that there should be some attribute which are common in this employee and department. So in employee and department, we have a common attribute, that is department number, but the name of those that attribute is different. In the employee table it is DNO, and in the department table it is D number. So what we have to do, we have to rename this department. So the department is renamed as department. We have renamed the table also, and inside that we have named D number, and we have renamed this attribute DNO, because in employee department number is named as DNO. So now we can perform natural join without specifying the condition. We will not specify that employee D number should be equal to department D number, because when it is natural join, it automatically knows which attribute should be joined. So based on D number, it will be automatically joined. So this is natural join. So the same thing only. In natural join, we will be specifying in the join, we will be specifying the join condition also. Here in natural join, we need not specify the join condition, but the only thing we have to specify is we have to rename that attribute so that the employee's D number and this D number are same. Okay, so that's all about join operations, and this is the reference. Thank you.